Good morning, everybody. So here we are with the last lecture of DSCI 511. Before getting started, do you have any questions about the labs, about the next week's quiz, or anything about the course in general? Okay, so just so you know, for next week's quiz, that quiz will cover only lectures 4 up to lecture 8, so half of the last half of the course. It will not include everything from the beginning to the end. Yes?
You mean 5 to 8? Or was on
5 to 8, yeah, right. Yeah. Okay, so we have looked at pandas for the last 2 lectures, and we are now familiar with its basic functionalities, how to do a little bit of data wrangling in pandas. And in this last lecture, we will review how we can deal with strings and also date times. And finally, I will show you a couple of extra features that are available in pandas to us, like hierarchical indexing and also some basic plotting. Okay, let's get started. So I told you in the previous lectures that in pandas, the way that pandas saves or stores string data is by using the object data type. So it treats it as a data type that when we have a mix of different objects, we will have this object data type. It treats it the same way, but you shouldn't worry about that when it comes to performance or anything, because it will be optimized for you. They are working on a string data type, and they want to replace this object type for strings in near future, but this is still in development. So when you see this object data type for your string columns, don't worry, there's nothing going wrong there. Okay, so I showed you how we do vectorized operations in NumPy, for example, instead of doing a for loop inside of Python in the previous lectures. The way that this multiplication works here is that NumPy refers to its optimized libraries in order to carry out this operation instead of running a for loop in Python. And this is generally what we want to do in Python, because otherwise our operations would be very slow. However, this type of operation is not directly applicable for strings like this inside of NumPy. So we have to do a manual loop like this here using a list comprehension in order to, for example, convert every string inside of this list to an uppercase string. Yeah, this one works, but obviously this is a Python loop, and this would be very, very slow in general. For 5 elements, for 10 elements, 100, 1,000, it doesn't matter, but when you get to larger data sets, this will definitely matter a lot. Okay, so in pandas, we have vectorized operations for strings, meaning that if a column is of the string type, then if we do string operations on them instead of running a for loop, pandas internally represents these strings inside of memory blocks, just like as NumPy represents numbers inside of contiguous memory blocks without fragmenting the data all around the memory, which slows down the computations. So it deals with strings in the similar way as it deals with numbers. This is why these operations would be much faster. The way that we can access string methods inside of pandas for a column that contains string values is that we do this. For example, S is a series that contains string values. This could be a column inside of a pandas data frame. And we should type s.stir, and when we do this, we will have access to all of the string methods that we are used to. For example, the upper.lower, and starts with, ends with, methods like that we know from earlier lectures. So here, if I do s.stir.upper, it will work the way that we expect it to, and this operation is now vectorized, meaning that it's as fast as possible. And again, the usual methods that we are used to are also applicable here. With the split method, we have this option that's pretty important, expand equals true, and this comes up in the lab as well. It means that when we split a string, we have the option to put the two parts of that string into separate columns, and this is what this expand means. So here I'm trying to split on the letter I, and whenever that happens, Pandas will create a separate column for me for the two parts of that string. For example, the name Florencia, that the split has occurred, and Pandas has automatically split the string into two separate columns, and for the column values that we don't have a value, it just fills it with nones. And again, we have this length method that computes the length of the strings. Again, something that we're used to. We can also index into the strings that we have. For example, here, I'm looking at the last letter of my string column. And this is not just limited to regular columns. I can also do all those kinds of string operations, even if those strings are stored inside of my index columns or index rows. So here, for example, I have these column headers and these row indexes, row labels, and suppose that I want to do some kind of cleaning up with those column headers. So you can see that the type of this df.columns is an index, expectedly, but I can do something like this on them. So df.columns to access the column headers, and then I can do .stir to access the string methods, and then, for example, capitalize all of the letters over here, and also replace feature with an empty string. So I don't want my column headers to be that long, so I'll remove the feature word over there. And finally, I'll strip the white space from the column headers. And if I do this, you can see that my index has changed to this, and compare it with what we had here. Okay, so you can see measured feature becomes measured, recorded feature becomes recorded, and we have capitalized the first letter of all of the column headers. Okay, now I can reassign it back to the data frame itself. I can do something similar with the row indexes, and the end result is something like this. So measured, recorded, row 0, row 1, row 2. So we kind of cleaned up the indexes using the same string methods that are available to me even for the columns. So this is just to show you that I can apply those string methods onto any column, row, or even the indexes which contain string values. Okay, so this is just a list of all of the methods that are available to us using this .stir methods. So yeah, this is a long list. Most of them are those methods that we are familiar with from previous lectures when working with strings. And the goal here is not to explore all of these different methods. It's just to show you that this is something we can do in Pandas, pretty similar to what we do in regular base Python. Okay, a couple of more examples here. For example, we might be familiar with the .replace method in strings. So here, suppose that I want to replace this sentence, like in the entire data frame, and I can do df.replace, and in a dictionary, I can provide the key as the string that I want to replace, and then for the value, I will provide what I'm going to replace that with. So I'm going to replace me with replaced. And then this number, 9999, with 10,000. And when we do that, it says replaced, and that number has also been replaced. Again, something that will be usually very helpful when you're trying to clean up data. And another example concerns regex, regular expressions. I guess you are familiar with regex now from DSCI 521. So we also have access to all of these regular expression methods that we have in base Python again. Just to show you an example how that works, suppose that I have this series containing these names, which are strings, and suppose that I want to find all of the names that follow this particular regex pattern. So what this regex pattern means is that here I want to start with something, and that something is this. And the square brackets in regex give us options, so different various options. And here I specify that I don't want those names to start with any of these letters. Okay? So my first letter cannot be any one of those letters that you see inside of the square brackets. And I want that to be followed by any number of characters in between. And also, I don't want my string to end with any of these letters as well. Okay, so basic regex pattern, and I can apply that to my series, and you can see that this name, my name, for example, starts with A, so that's not acceptable. It returns an empty list. And for example, this name follows this pattern. This name also follows this pattern, so these are the ones that are going to be returned to us. Again, a very, very useful feature. Regex is very powerful for string matching, and you can do like really complex stuff with regex. And this is available to us in pandas in a vectorized way. Okay, let's do something with this regex thing inside of pandas. So here I have my IMDb data set. Okay. And suppose that I want to find all of the movie names that start with the digits. Okay. So in regex, I can specify the start of a string with a caret, like this. And a digit is denoted by \d. And if I run this, so .stir.match, it will return to me a Boolean series that returns true wherever that regex pattern actually satisfies that particular element satisfies that regular pattern, that regex pattern. So what I can do is that I can create a mask with that pattern, because that's a Boolean series. I can use that as a mask and then supply it to my data frame, my original data frame. And then in this way, I can get back the rows for all of the movies that start with a digit in the beginning of their title. Okay, so again, I'm using this as a Boolean series, as a mask, and then I provide that to the original data set to return those rows that satisfy that condition. Another example, suppose that I want to find all of the movies that are directed by Christopher Nolan and James Cameron. I can provide a regex pattern like this and use .contains, meaning that I want the strings that contain this particular pattern. And this, in the beginning, means that I want my pattern to be case insensitive. And this also provides an OR condition, this pipe. And if I run this, again, this returns all of the movies directed by these two magnificent directors. Okay. All right, one other example. I want to split the genre column on a square on a comma, on a colon, a period, an exclamation mark. And I want to expand the columns based on that. And you can see here that the genre column has been expanded into 4 columns instead of just staying as 1. And it has been splitted, for example, on the comma values for this particular genre, for example. And for the columns that we don't have a value, you can see that the word none appears for those elements. Okay, so that's about it for processing strings. There's obviously a lot more to it, a lot of other options, a lot of other methods with different functionalities, but this is just to show you how these string methods work, to to tell you that these operations are vectorized, they are super efficient, so you don't need to worry about any kind of computational overhead. Okay, any questions about this part? Okay. All right, so now let's talk a little bit about working with date times in pandas, which is something that comes up a lot when you're working on several different types of data set. You will learn about a particular type of data set called time series in your DSCI 574. That's an entire course about modeling time series data. So you will work a lot more with this kind of data in that course, but here we just want to learn how pandas treats this particular kind of data. So in Python, we have a built-in object called datetime, which supports basic datetime operations and storing datetime information. And again, yeah, this is it comes with the base Python. And what it does is, this is just an example of a class that defines an object datetime that helps us organize information about dates and times. And it comes with its own methods. So here, datetime, it accepts these arguments. I can provide the year, the month, the day, hour, minute, and second, and it will return to me a datetime object. Okay. One thing that I can do with this datetime object is that I can parse a string that contains date times, meaning that I have a string that contains that information, but not exactly in a way that I can supply to those parameters over there. So I can basically process that string in a particular way and tell Python what each of those words or characters mean. And then this stir p time, meaning stir parse time, automatically processes this string according to the pattern that I provide. So for example, here I tell Python, hey, the first thing that you see over here, that's going to be the month name. The second thing is going to be the day and the year and then the hour and then the minute. And you can find the format codes over here. So if you are curious to know what each of these letters stand for, you can refer to this link that I have provided. Okay, let's go back to, yep. And when we do that, Python understands that and parses that string for us, processes that string for us accordingly. There is also this date.stir ftime, meaning stir format time, which we can use to extract parts of a datetime. For example, if I want to format the output of a datetime object in a particular way, for example, if I want to have just the year and the hour, for example, I can do that using, again, these formatting strings and basically output anything that I like in any format that I like from that datetime object. Okay, so there are these two built-in methods, stir p-time and stir f-time. One parses the strings, the other one formats the datetimes for us. But let me just show you this option as well here. So we can also use this time delta object, which is the difference between 2 points in time, and we can use that to do time arithmetics or date arithmetics. For example, here I'm adding 7 days to the previous datetime object that I had. Again, this is something that is defined inside of the class that defines the datetime object, very similar to something that you have done in Lab 2. So yeah, this is doable. You can do arithmetic with datetimes. However, when you want to work with large data sets, this is not a very efficient way of processing date times. So let's see what other options we have. In NumPy, we have this datetime data type, which we can use to define arrays of date times. Okay, so yeah, you can see the date time, the D type comes up as datetime 64, and it's an array that contains date time, so NumPy understands that and understands the kind of operations that is possible with this kind of data. It also, for example, it supports a range, which produces a range of dates and date times using the start and the end values. Okay, and again, we can use the time delta inside of NumPy to, for example, here I want to add 2 months to this array of date times, and I can do that in NumPy. All right, so why am I mentioning these things here? It's because Pandas built its functionality to work with datetime objects on these NumPy operations that are defined. So basically what Pandas does is that it consolidates and collects all of these different methods for date times and provides all of the features to us in just one place. Okay, so Pandas again is built on top of NumPy, so most of these operationality is borrowed from NumPy, and then Pandas extends most of it to more different features, more extra features for working with date times. So in Pandas, we have different types of data types for working with date times. The first one is a timestamp, meaning a particular point in time. So a particular date and a particular hour, minutes, and second. That's one point in time. It also supports time delta. As we have seen, it's a period of time that we can use to do arithmetics with date times. It also supports this period object, which stands for, which stores a span of time. For example, it's the span of a day, span of a year, and things like that. And also it supports a data offset, which we don't talk about here. It supports more advanced functionality. For example, it supports some calendar rules. For example, to ignore the days that are not business days when you want to do arithmetics, things like that. Let's see how we can create date times in various ways in Pandas. So the easiest, not the easiest, the first way that we look at here is to create these date times from scratch manually. So what we can do, pd.timestamp, we can provide a timestamp to that in various ways. We can provide it as a string formatted like that, or by supplying those arguments to the parameters, or by supplying a datetime Python object, and all of that creates one single timestamp for us. Usually this is not something that we do. We don't create these timestamps manually, but just for you to see that this is possible to do, to create just a single timestamp object in Pandas. We can also create a period object in a similar manner. And note that with the period object, we have these start time and end time attributes. That could be helpful to, for example, to check whether a particular timestamp is within a particular period. So here, I can check whether this point in time happens to be in this period. So I can do that, point in span, true. This is an example of how a period data type can be helpful. All right, but just, yeah.
Just a question. You're showing us that you can use, for example, a period which is a whole day. Can you use a period which is multiple days? So you can use this, a span method to...
Oh, yeah, sure. So the question is, can we use this period object to create a span of like several days or several hours? Yes, definitely. This is just an example. It could span 1 second, span a minute, a day, or even 10 years. So the point is that it's a span of time instead of just being one point in time. Yeah, that's definitely possible. Okay, and the thing about the period object is that if, for example, it's a span of a month, then there is no day or hour or minute or second, and that creates some storage efficiency, basically. So if you really want to represent a span of time, then you don't need to store it as a timestamp, and you don't need to store all of that extra information that only adds confusion to our data set. You can directly store it as a period of time and store some storage space. Okay, usually we would like to create like arrays of date times, not just like single values. The way we can do that is that we can use these helper functions that are provided to us in pandas. For example, pd.dateRange works very similarly to ranges of numbers, but it works for date times. For example, here, I'm creating a range of days between this particular date up to this particular date. And I can specify the frequency here. So here, the frequency is daily. I can do, for example, hourly, and then this will be a much longer range. Here we have 241 elements, but if we revert back to daily, we will only have as many days as you can see on the screen here. Okay, so we can change the frequency to create as many timestamps as we like. And we can do the same thing with the periods. Again, there's this frequency argument that we can use to generate as many items as we like. And just like Python datetime objects, we can also do arithmetics. So the syntax is very clear, very helpful, very flexible. So we can add 1.5 hours to the timestamps that you have generated. So for example, here we have a date range here, and you can see that the hour is 12. And here, if I do this, you can see that the hour is now become 13:30. And yeah, this is just an example of how we can do arithmetics with time. Okay, and this can be, obviously, this can be days, that can be years, can be seconds, anything that you like. And Pandas also has this NAT, not a time, which just denotes the fact that this particular element inside of a column that stores datetime is not a time. It's just in case that you see it somewhere, this is what it means. So basically an unknown value inside of a datetime series. Okay. So we've been exploring different ways to create these datetimes. One other way is to use existing data. For example, if I have these strings inside of a list in Python, I can also provide them directly to this datetime function, toDatetime function, and that creates a datetime index for me like that. So it automatically parses these strings. And if your strings are formatted in an unusual way, you can also provide the particular format that the data comes in. So here I'm saying that the first element that you see is the year, the second one after the white space is the day, and then the last one is the month name, not, for example, the month number. Or you can also use a dictionary. Again, another different way, not very important in this case, but just to show you that this is possible. And you can convert a datetime series to an index to use as an index column or an index header, or you can also do the reverse, convert an index to a series. All of that is possible inside of Pandas. Okay, the other way that is usually the way that you create datetimes is by reading data from a file, like the way that we do it in the lab. So we have this data set. We can read it with this read CSV. So this is a cycling data collected by someone who rides a bike to UBC every day. And you can see that it contains some information about the date, the name of this particular observation, and also the time that it took, the distance, and some comments. And in this case, although you can see that this column has been named date, and you can see some date times, but this is actually not a date time. So if you look at the index, you can see that it says dtype object, so meaning that it's just a plain string. Okay? So you can't do those kind of datetime operations with it because it's just a string. In order to make sure Okay, so you can also check that out here. df.indexD type, it says object, meaning that it's a string. What you can do is that to supply this parameter, parse dates, and set it to true, meaning that look at the index column and treat it as date types. So try to process that in order to convert it to a date type. So as soon as I add that parameter, this time this is date, but note that the format has changed. So here we see, for example, September 11, 2019, but here we see this unified format, and this is an indicator that something has changed. And if we look at the data type, we can see that this is actually a datetime index. So remember, we can use this parse dates parameter to process the index column, and then yeah. Okay, so one thing that might come up is that my datetime column might not have a parser-friendly format. For example, the format might not be like this, that Python understands, that Pandas understands. If it's in a very particular format, you can also use this argument called date parser, which accepts a function that you can define to tell Python how to grab each element inside of that string and how to treat it. So which element is the day, which element is the month, and things like that. You can explore all of that inside of the Pandas documentation. There's very detailed information about how each one of these parameters work. For example, if I look for date parser, I can find that here. Okay, it says that date parser function to use for converting a sequence of string columns to an array of datetime instances. Okay, and you can also find examples about that here. Yeah, not here, but if you look for it, you'll find it in some. Yeah. Yeah, it's something in the documentation, not right here, because it would be there should be a lot of examples if they want to include on this page. But anyways, this is just to tell you that you can find the detailed information about all of these arguments here. Okay. Now comes the more exciting part about this. I'm not particularly excited about this stuff, because it's just to tell you how the API or the interface of Pandas works with this kind of stuff. But again, we have to learn how it works because it comes up a lot. But this part is a little bit more interesting. So let's take a break before that part, and then we'll be back in maybe 5 minutes. Okay, so now let's talk about how we can retrieve data from a data frame that has a date. Okay, the break is over. Okay, so now let's look at how we can retrieve data from a data frame based on datum values. So here we have the data frame like that this column, this index column is already in a datetime data type. And suppose that I want to retrieve all of the rows that happen to be in this year, 2019, and in this particular month over here. And I can do what's called partial string indexing. So I don't need to provide the entire row label as a datetime. I can do partial string indexing. So here I can just provide the year and the month, or I can even do something like this. It will still return all of the rows that belong to year 2019. Okay? However, this has to happen from the beginning of this datetime here, so I cannot type something like this. I cannot do this. It will throw an error. So it should start from the beginning of the datetime, and then in that case, this will work. And I'll tell you how you can do, how you can search for like just a particular month or a particular day or hour or so. Okay, again, we can also refer to specific days in a month and in a particular year, and that returns only those 2 days. So the 10th day of October 2019. Okay, and I can also obviously provide an exact matching string like that, and it will bring back only that particular element, that particular row. Okay, and slicing also works. So we can slice a particular period of time and return the rows that happen to be in that slice of time using the familiar column notation. So we can do that, but it's complaining to me, saying that slicing on non-monotonic datetime indexes will return an error in the future. So it means that because this datetime column is not sorted already, this type of slicing might not return to you what you're expecting. Okay, so you're slicing, you're telling pandas, return all of the rows to me between the first day of October until the 13th day of October. However, if the data frame is not sorted, there might be some rows in between that belong to year 2022, and it will still be returned to you because Pandas does not understand that. It only looks for the range of rows. It doesn't look at the range of dates per se. Okay? So in order to avoid this particular warning and to be clear what you want to do, you can sort the index first and then do the range slicing, and this will be what you expect, because everything between the first day of October, the 13th day of October, will be actually what exists in the data frame because it is already sorted. Okay. One very helpful method is this between time. So if you want to return all of the rows that happen to have occurred in a particular, between a particular set of times, so for example, between this time and 1 a.m., you can retrieve all of those items like this. And these do not belong to a particular date, but to a particular span of time. Okay. Now, so now what we can do if we want to return, for example, all of the rows that happen to have a date time for the month of August. This is something that comes up in the lab. So you want to look at all of the values that belong to a particular month, not a particular year, because we want to find like the seasonal patterns or things like that. So we want to only return those rows that happen to have occurred in a particular month, in a particular year, or the weekday. In that case, we can do what's called decomposition. So we can use this syntax over here. We can access the index. So if you look at the index, this is the index. And because it's a datetime index, there's an attribute called year. And that only returns the year values to us. Okay? Now, what we can do with this is that this is something that I ask you to do in the lab. You can create a new column based on that in your data frame. For example, you can do something like this. My year column, and then set it to df.index.year. And now my data frame should contain a new column, which you can use in order to slice your array. So here you can see that I've kind of extracted that year and created a separate column with that. And now I can easily slice that using .look. Okay? And you can do the same thing with any one of these attributes, like year, the month, the hour, the second, and anything that you like. Let me change it back to this. Okay, you can extract the second, the weekday, also day name. So if you want to return all of the rows, for example, that belong to observations made on Mondays, you can save it as a column, as a weekday column, and then try to slice the data frame using that, or index into data frame using that. Or things that have happened, for example, only in the month of October. Okay, so one last thing about this part is that whenever you want to access these attributes, like the day name, the year, the weekday, the hour, and anything like that, it only works in this way if it is an index. If it's just a regular column, then you have to use a syntax like the string methods. So, for example, here, if I have a series of date times like that, if I type s.year, that won't work. So you have to first type s.dt, meaning that I'm trying to access the datetime methods and then refer to the year attribute. This is very similar to what we did with string columns. We do .stir and then, for example, upper. Okay, this is very similar to that. So if it's a regular column, you have to type s.dt first, and then you'll have access to all of the attributes and methods provided for datetimes. For indexes, you can just type df.index.year.weekday. Okay. Any questions about this part? Yes.
I'm kind of having a question whether, like, the DT is not df.
Oh, okay. No, so it's a question. This DT that we see over here, that's just kind of the sub-attribute of any column that contains a datetime type. And by that, when you try to reach into that, it will provide all of the methods and the attributes that are defined for a datetime. It's very similar to the .stir. So it's .datetime. Yeah. Okay. Okay, now, yes. Pardon me?
The time is all the time in the 24-hour system. I mean, what is the data frame includes the time using the half hour?
Okay, yeah. So good question. If the hours in the datetime index, if they're based on a 24-hour format or 12-hour format, what happens? So this depends on how you load your data. So for example, if you provide a date parser that looks for those AMs and PMs and stuff like that, then you can either load it as it is to interpret it like that. I don't think that Pandas supports that in that way. I think it's only 24-hour format, but you can read in data that contains those AM and PMs and convert it to the 24-hour format. I'm not sure about that. I have to look it up, but I think it doesn't support the 20-hour format. Yeah. Okay, so there is an operation with that is very common. People do it very commonly with time series data. It's called resampling. And it means that if I have a data frame that has rows belonging to particular points in time, then there are situations that instead of having data that is not regularly aligned, like is not, let's say it doesn't have a regular time step, then we might want to create a data set that has a regular time step so that the spaces, the time deltas are equal between all of the rows. For example, if I have a data set that contains data for today and then data for next week, and in next week it contains data for all of the days, so this is irregularly spaced. And for some kind of operations with time series, for some kind of analysis, this might pose some problems. So the way that we deal with this is that we try to resample the data, meaning that we regenerate a data set that's regularly spaced based on the irregularly spaced data set that we have. So the way that we can do this in Python, in Pandas, is by using this resample method. And then inside, as an argument, we can provide the frequency that we like. So let's see an example of this. That will be easier to understand that way. So for example, here, you can see here this row belongs to the 4th day of October. And then after that, we have data for the 9th day of October. So we don't have any rows in between. However, some other rows contain more than one data points, more than one observation per day. This is irregularly spaced, and this might cause problems for particular applications. So the way that we can deal with this is that we can do df.resample and resample everything to regular daily data. And resample works like the group by. So by itself, it doesn't return anything to you, it just creates the object. So you have to do some kind of aggregation on that, some kind of like applying a mean, a maximum, or something like that in order to return something from the resampling. So if I do this, you can now see that everything is regularly spaced. We have data for all of the days. And you can also notice that for some of the days that we have more than one observation, they are all averaged. And the other thing that you can notice is that for some of the days that we didn't have any data, they are filled with unknowns, because we cannot just create data out of like thin air. We should know something, but we should do something about it, and that's based on the assumptions that we make. Okay? One way, for example, to deal with this is to take, let's say, the average of the values that come before these rows and the ones that come after these rows, take the average, fill those NANs with the average values, or fill them with the values that come before or the values that come after. That's a decision that we have to make for the unknown values, but we can generate these regularly spaced data with the resampling. And there are two kinds of resampling. We either downsample, meaning that we take a bunch of rows and take, for example, the average and compress them down to one row. For example, we convert each 7 days into just one observation for a week, and then we take the average. That's downsampling. There's usually not any confusion about that. But when you do upsampling, meaning that you're trying to produce data, then in that case, you will encounter these unknown values that you have to fill yourself. Okay. All right. So one thing about this resampling, again, something that comes up in the lab, is this argument over here called kind. And instead of you resampling the data and then manually convert like the index column into a period, then you can provide the period type right here, and that converts the column to a period. This is something that I asked you to do in the lab. So by default, it is just like regular date time, and you can do kind equals period to turn it into a period data type. Okay, this time you can see that if we run dfr.index, you can see that it's a period, but if we remove that and then run this again, it's a date time. Okay, just a shortcut. Yes? Oh, you don't put anything? I think that's a required argument. Let's see. Or maybe not. Oh, yeah, that's a required argument. Oh, just put a D. Okay. I think it should work. Yeah, it works. Yeah, so 1D and D is the same. Yeah, and you can also have, 5D, that's, you're not limited to just 1D. Yeah. Okay. Any other questions? Okay, so all right, so one other thing, again, just to show you an example of how powerful these methods could be, is that for some particular applications, you might only need particular business days in the data. You don't want the data belonging to, like, let's say Saturdays and Sundays. You only want business days. One thing that you can do is that you can resample to one business day here. So there are a lot of options for how you can sample your data, and they're all provided here in the documentation. You can look that up. But just to show you an example here, I can also resample to business days. And when we do that, notice here that we don't see any value recorded on a Sunday or on a Saturday. So this may be something useful for financial institutions, for example, when they look at stock data, things like that. Okay, so we are done with date times. Again, there's a lot of other things that you can explore in Pandas regarding date times, regarding the strings, but this is just to show you a demonstration. Yes?
Question, what's the best way we can deal with different time?
Yeah, so somebody else also asked this question. I haven't ever dealt with time zones inside of Pandas myself, but I'm sure there should be some way of dealing with that inside of Pandas if you look that up in the documentation. I know that this is a concern when you deal with databases, online databases that people from different parts of the world try to retrieve data from. When you retrieve data from these databases on your phone, on your computer, you see that it's always in local time, for example. I don't know how this is handled in Pandas, but there should be a way to do this. Yeah, I haven't used it myself. A lot of Pandas. So one other topic that's won't be part of the quiz or the lab, but I think could be very useful, is hierarchical indexing. And since we have time, let me just walk you through a few examples of what this means and what we can do with it. I think this will be pretty helpful. But again, this is optional. This won't be on the quiz. Okay, so suppose that instead of having one level of labels for our rows or for our columns, we need multiple levels. Why would that be something that we need? So for example here, suppose that for each data point that I have an instructor and a particular year, and here I have the number of courses that is recorded for that combination. So in year 2020, I have taught one course. However, in 2021, the same person has taught 3 courses, for example. And there is not, so if you can represent it as you can represent the index column as like a series of tuples in order to represent that data. But this is not a very efficient way to do this. So here I've used just simple tuples in order to represent that data. And suppose that I want to index into that. So I will have to use this very messy syntax. And if I want to do something more interesting with my data, suppose that I want to get all of the values that are recorded for year 2020, regardless of who taught which course or how many courses, then I have to do something a lot messier. So something like this. I have to look for I in s.index, and whenever the second element is equal to 2020, then I retrieve that item, and it gets very complicated very soon. Okay? So it does work. We can do this, but again, it's not a very efficient way to do this. So the way that Pandas solves this problem for us is by using, instead of single indexes, we can use multi-indexes. And this is nothing but various levels of indexes, not just one level that we are used to. So here I'm creating a multi-index object to represent those two levels of indexes. And let me now create the same data with this multi-level index and see how it looks like. Now, not only it appears much nicer as displayed on the screen, it also works in a much more efficient way. So you can quickly see that the data that is recorded for me, the data that's recorded for other people, you can see there's two different levels of indexes. The 135563 that you see is the actual data, and what you see in the first two columns is the indexes. Okay? So now I can index into this series much easier in a much more intuitive way. So if I do s.lock and then retrieve all of the items that are recorded for this particular index, see what happens. Yeah, it returns these two items for me, exactly what I wanted. And now it looks much more cleaner and generally much more nicer. And suppose that I want to retrieve all of the items recorded for the year 2020. So I can return everything for my indexes and only pick the value 2020. Everything in the first level of index, so I don't want to make a distinction between those different instructors, but I only want to pick data for the year 2020. I can do that very easily like this. And compare this syntax with this syntax. So it's much, much easier and more intuitive to read this instead of that one. And I can also index into that series and go into different levels of the indexes to retrieve a single item. For example, the data that's recorded for Arman in 2021. Arman 2021 is 3, and this is how I get that item back. Okay. So there are various ways that we can create multiple indexes ourselves, but usually this is not what we do. Again, it's when we read in data or when we melt, for example, tables or pivot tables, this is something that might happen. So in the previous lecture, you saw that in some situations we had two index columns instead of just one, especially with the pivot table example that we saw. So this is just an example of how you can create it manually, but usually this is not something that you do. Okay, and now I just want to show you a couple of methods that come up when we work with multiple indexes. One of them is unstack, and this means that, so what unstack does is that it takes this data frame, this series that we have, and converts it into a data frame. How it does that, it actually works in a way that's very similar to the pivot method. So it looks at the data set, okay, it looks for the first level, and then anything that it finds in the second level of index, it creates a column for that. So for each unique value in the second index, it creates a column for that, and it basically unstacks the indexes. So the indexes are stacked here, stacked side by side. It unstacks that into multiple columns, basically, and creates a data frame for you based on that. And stack does the reverse. So it takes in a data frame and converts particular column headers into separate indexes. Okay, now let me just show you a couple of examples how we can use hierarchical indexes. So here I have 3 data frames for each instructor, And there are the courses that these instructors have taught and the number of students they had in each course. Okay, that's the data frame. And now if I use the concat function that we've learned about in the previous lecture, if I provide this parameter keys, then something really nice happens. So here you can see that instead of just concatenating the data frames all into one single index data frame, it actually creates multiple indexes for different data frames that I have stacked, that I have concatenated on top of each other. So I can provide the keys as for each different data frame here. Okay, this is the way that I want to name those data frames, and they appear as multiple indexes. So instead of just putting them on top of each other, I have created a multiple index for that. And this is a nice way of organizing data in a cleaner way, basically. And now what it does for us is that I can now index into my data frame in a much more intuitive way. So to retrieve data for myself, I can just do .lock Arman. If I didn't have something like that in the above, that would be a little bit more involved. And here, for example, S3.lock Arman 2020, that retrieves just one single row. And we can also access the deeper levels inside of that. So I can also retrieve items from each column. The way I can do that is to retrieve items from the indexes first, and then retrieve items inside of the course. Instead of that, I can also provide the multiple indexes inside of a tuple. It works in the same way. And yeah, this is the same thing. Okay. One thing that I can do to make querying data easier is to name those two indexes. So for example, here, they didn't have any name. So you can see that they don't have a name. If we name those, like this, name and year, then I can use the query method in very easily like this. So return back to me anything that has year equal to 2021. And that works as it's expected to. Okay, so the rest of this is just a bit more details. Any question about multiple indexes before I show you just a couple of ways to plot data? Okay, so in Pandas, if you want to just quickly take a look at your data and see how different columns or different rows look like, there are some basic plotting functions implemented for you, and you can use them very easily by just calling a .plot method or something like that. So let me show you that. So for example, in my original cycling data set, we had a column called distance, and if I just want to quickly see what distance looks like, I can call .plot and then specify the plot type that I like, and then this will give me something like this. So just a quick look. It's not formatted really nicely. You learn a lot of detail about how to plot, how to make nice visualizations. But this is just for you to see what's going on real quick. You can also chain different operations together. For example, the cumulative sum here, and then apply plotting in the line. And you can also customize your plots in a couple of ways, different font sizes, line widths, colors, and stuff like that. And it also works. Yeah, it can save you from writing a few lines of code just to plot your data. So you just do .plot, and there you go. And there are different types of plots: histograms, box plots, area plots, and a lot of things like that. One particular type that I really like is this scatter matrix that plots each column against the other columns for you. This can be helpful for when you want to see correlations between data. And and that's about it for this lecture. But we have 5 minutes left, so this is the end of this course. I hope if you didn't have a background in Python, I hope that you've learned something useful about Python in this course. And what I focused on in this Python course was not really to teach you only about the syntax. I really hate that about programming courses when they just say, okay, here is how you define a function. I can figure that out myself by just looking at documentation. I tried my best to show you and teach you about the inner workings of Python, how Python deals with data, how Python organizes data, what is the design philosophy. So the whole design philosophy of Python is based on object-oriented programming. So now if a new package comes along in Python, you know that whatever it is, it defines a set of objects with their particular way of organizing data and some particular methods that operate on that data. Whether it be pandas, NumPy, anything else is designed with that philosophy. So this is what I wanted to really emphasize in this course, especially in the first few lectures, and not just teaching you about just syntax. And this last two lectures, especially this one, was a lot about syntax, which I don't like that much, but this was something that I had to do because you need a lot of these methods and functionalities in Pandas for your later courses. So with that, thank you so much for bearing with me in this course, for tolerating the boring lectures at 8 a.m. if they were, but thank you so much. I will see you either in the lab today or next week for your last quiz. Thank you so much. Have a wonderful day. Thank you. Thank you so much.